In the user module, we manage the user list of materials, list of thicknesses, and list of machines. The user also defines the default types and parameters of the leads in and leads out for external, internal, and small holes according to the machine selection. Please note that for small holes, we define the parameters as a function of the hole's radius, including the overcut at the end. A gap is defined positive in the leads out, and an overcut is negative. The info module is the user's controlled database. In the user attributes, in machine attributes, we can see the list of machines. With 1 or 0, we indicate which machines are going to be available for selection when we start a new order. In the attributes, for each combination of machine, material, and thickness attributes that we use, we enter or modify the feed rate. For each machine, according to material and thickness, we enter or modify the kerf. For each machine, according to material and thickness, we indicate with 1 or 0 if that combination of machine, material, and thickness will be open for selection when we start a new order. Back to the user module, we go to defaults and to order control. What we would like to do is have the thickness of the order as the offset between parts and the margin to the plate edge. For this, we use the attribute icon. We go to Program Attributes and we select the thickness of the order as the default for the offset between parts and the margin to the plate edge. We replace a fixed value in defaults with an attribute. We can do the same for lead parameters and all other default values. In Start, we select a model and we go to the Order module to start a new order with parts from the selected model. In Order, when we start a new order, we can see the selection available for different materials and thicknesses. We can see that the default for offset and margin are equal to the thickness for the order. We are back in the info module, in the material and thickness attributes. It is not logical that for a thickness of 1, we will have an offset between parts of 1 millimeter. We are going to start a new attribute where for mild steel, as we have in the example order, we will have an offset of 5 for thicknesses up to 5, and above 5 the offset and margin will equal the thickness. Back in user defaults, we change the defaults for the order offset between parts and margin to plate edge to the new attribute in the info database. In module order, we start a new order. We observe how the speed, kerf, offset and margin change according to the material, thickness and machine selections. For an order of mild steel and 8 mm thickness, we select the amperage of 100, which gives us the speed and kerf from the info database. After the selection of plate and part quantities, the order is defined. We nest the order. Please note that parameters like the offset between parts and the margin to the plate edge appear as they were defined in the database, but can be modified in the order. We cut the order. Please note that all parameters like lead parameters or automatic cutting parameters can be defined in the info database and can be modified in the order. In NC, we check and create the machine file. For that, we use the generic post in combination with the info database. This combination allows us to get the best cutting quality possible with the available controller and machine. In the post module, we can create a new post or modify an existing post. In commands, we can enter or modify the commands that define each post that we have in the list. In stations, we can see that for external cutting, we have M21 for cutting on and M20 for cutting off. The same commands for internal cutting. For small holes, we have in addition M14 to disable the height sensor in the beginning and M15 to enable the sensor in the end. In NC, we can see the commands in the machine file. In POST, for speed control, we use 100% for the database speed for external and internal cutting. For small holes, we use 60% speed for the lead and 50% for the hold. In NC, we modify the database speed to a round number for easier checking. We can see how we can control speeds in the machine file. In info, for better speed control in a hole, we start a new attribute for percent of cutting speed. We enter values in mild steel and amperage of 100 to check in the example order. Note that for a thickness of 8, the interpolation will give us 55%. In the generic post, we enter the new attribute for the hole cutting speed. In NC, we can see that the lead for the hole is cut at 60% speed and the hole at 55% of 3000 millimeters per minute speed. In post for external and internal cutting, we want to have 85% of the speed for the lead and 5 millimeters into the part to change to 100% of speed. In addition, we want to disable the height sensor 10 millimeters before the end of the cut. In NC, we check the additions to the generic post. In info, in computed attributes, we add another attribute. We want to disable the height sensor of 1/4 of a second before the end of the cut. We can use the value of attribute material plus thickness plus amperage for speed. For better accuracy, we go to Program Attributes and we pick the current speed in the cutting sequence, as the database speed could be modified. In post, we insert the computed attribute instead of a distance value, as time will be a more accurate measure. In NC, we see that the distance to disable the height sensor in 12.5 millimeters, which is a quarter of a second at speed of 3000 millimeters per minute. In post, in corner commands, in angles of up to 85 degrees, we want to disable the height sensor 5 millimeters before the corner and enable the height sensor 3 millimeters after the corner. Please note that we can give a different command to different ranges of angles, and we can add speed and other commands. We can have different commands for inner and outer corners. In addition, we can modify a corner in a range of angles to round it or to extend it with an arc or triangle for sharp cutting. In post, in small arc commands, we enter similar commands. In NC, we can see the corner commands in the machine file. Post, for better cutting of complex parts, depending on the controller, we want to apply commands when in the part we have a string of small segments. In this example, we use G261 for better and faster cutting of small segments, and we use G260 to return to regular cutting. In NC, we can see the commands that are applied to a string of small segments.